Find an approximation for cos 2 theta minus cos theta when theta and 2 theta are both small and measured in radians. Hence, find the limit as theta goes to 0 of cos 2 theta minus cos theta over sine squared 2 theta. So, for small angles, theta measured in radians, then cos theta approximately is equal to 1 minus theta squared over 2, and sine theta is approximately equal to theta. So, for cos theta, we will substitute in 1 minus theta squared over 2. But for cos 2 theta, what we'll do, we'll put 2, instead of theta here, we'll put 2 theta, but you must remember to put it in brackets, and that will become approximately equal to 1 minus 2 squared, which is 4 theta squared over 2. Now the 4 and the 2 cancel, and we're left with 1 minus 2 theta squared. Therefore, cos 2 theta minus cos theta will be approximately equal to 1 minus 2 theta squared minus 1 minus theta squared over 2. And we're going to have 1 minus 2 theta, minus 1 gives me minus 1, minus minus gives me plus theta squared over 2. Now the 1 and the minus 1 will cancel out, and then minus 2 theta squared plus theta over 2, theta squared over 2 will give me minus 3 theta squared over 2. Right, to find the limit, so the limit as theta goes to 0. So the angle, we're considering small angles, so this bit here, we've already decided is equal to minus theta squared over 2, divided by, now sine theta approximates to theta, and therefore sine 2 theta will approximate to 2 theta, and then the sine squared of 2 theta will be 2 theta all squared. So 2 theta all squared is 4 theta squared, so combining it with the 2 there, we're going to have minus 3 theta squared over 8 theta squared, using our rules of division of fractions. That's 4 theta squared times another 2, that gives me 8 theta squared. The theta squared cancel out, and I'm left with minus 3 over 8, which as a decimal is minus 0.375. Now you can check that result on a calculator, or like I've done here using an Excel spreadsheet. So this is the values of theta, 0.2 all the way down to small, and what we can see once we work out the limit, you can get the formula here for what I use for the limit by pausing the video and looking at that. So putting the correct limit in. So scrolling down here, obviously the smaller we get it, when it gets very, very small, we can see that we're going to get minus 3/8, okay, but you can see it is approaching minus 3/8. Okay, so this has been a video to show how to find the limit of a trig function when the angle is measured in radians, and the limit, we want to know when the limit is approaching 0. I hope you've understood, and I thank you very much for watching.